let's begin. We stopped yesterday here. We got the ones and twos mean before and after?
Yes.
All right, here are the remaining three gas laws. No. Now, where R equals, and then it's off the screen. No. Yeah.
That's not working. That's too far away. There you go. I hope I didn't make you sick.
Okay, so this says the combined gas law is P1V1 over T1 is equal to P2V2 over T2. The ideal gas law is Pervner, PV equals nRT. Dalton's law. Where's Felix? That's dumb. That's not funny.
That's not true because I texted him earlier today and he was very much alive.
Well, his phone was at least.
Unless someone else texted.
Right.
So then that would be
Dalton's law of partial pressure, P total is equal to P1 plus P2 plus P3.
Wait, where R equals what?
We're going to, this says where R equals, and I need to zoom over there for you to be able to see it. Yeah.
I'm doing the notes from yesterday. It went away. I was.
All right. No? Why are they all orange? Oh, they look all orange from here. All right. I need your attention. Still need your attention. But it's okay, Avery, if you don't want to give me your attention. It's cool. I know you're too cool for this. All right. Let me explain Dalton's law because it's the simplest one. Pressure total is equal to the sum of its parts. Super simple, right? So if I say the air in this room is got one of the gases has 5, one of the gases has 2, and one of the gases has 1, your answer is going to be 8. Use add them up. Usually, though, it gives you the total and asks you to solve for one of the individual pieces, which you just subtract, so no big deal. Okay, so that one's easy. Combined gas law is also very straightforward. All the before the change variables and all the after the change variables, right? So before and after. Pervner is the only gas law that does not have befores and afters, that does not have a change. And so let me give you two different wordings. One of these would be like, if I have a gas at this pressure, this temperature, what will the volume be if I change the pressure to this and the temperature to this? You see how you have befores and afters there? Pervner is going to be, I have a container of gas at this temperature. What's its pressure? So you're not changing anything. Good morning.
Oh, yeah. Nice to see you again.
Mm.
Oh, and Thank you for putting the green.
You're welcome. Thank you for not being a bum. Again. All right. Okay, so, but we don't know what R is. We do know what N is. What is N? Lowercase n?
Newton. That's
Oh, we haven't learned it yet. We are going to learn what N is. Okay. And we are going to learn what R is, but I don't want you to do that yet because we need to fill out this table first. And that is the full table. Which one? Retake or original? Make up so you don't have nothing.
No.
Find your center. All right, got your table reproduced?
No.
Oh my cats, hurry it up. This one, notice it's broken into 3. Oh my cats.
I need a ruler.
You take the test. I'll have you sit in the last station, but leave your cell phone with me, please. Cell phone. Fran, would you like to use one that's already set up and mounted to the wall? It's on the other side where I keep pointing. Oh, you are so cute. You have so many other gifts. I wasn't too precise. Let's just stick out there and you can use mine. All right, you ready? All right, the first variable that we're going to talk about is temperature. Yeah. That is so funny. Yeah. Temperature. Capital T. The variable name is temperature. The unit is going to be reported in Kelvin, capital K. And things to know about temperature.
I need a pencil.
Oh. All right, so we need to talk about something called absolute zero. So, tell me what gas particles do.
They float.
They're like zinging around everywhere, bouncing off everything, right? That has to be an lab station. And there's the sharpener's in the back. All right, tell me what to do to make this a liquid. I need your attention, folks. You're distracting her. All right, slow it down, right? So I'm going to slow it down, and I'm going to slow it down, and I'm going to slow it down. And eventually I'm going to get slow enough that they're not just bouncing off each other. They're kind of staying near each other, right? And sliding past each other. Yes? All right, so this is a liquid. Tell me how to make it a solid. Slow it down. So I'm going to slow it down even more. And so they're right next to each other. But notice they're not still. They're shaking in place, right? Tell me what to do to make them slower. Cool it down. Remove heat. Remove heat. Remove heat. Remove heat. Now they're perfectly still. This is absolute zero. You can't get any colder than that because you can't get any slower than that, right? And temperature is speed. So absolute zero is the temperature at which all motion stops. And it is equivalent to 0 degrees Kelvin. Might want to empty it. There is. It's just breaking off as you go. All right. So let's talk about absolute zero. First of all, here's the values of absolute zero. Swear to Buddha and all his saints. Will you move to the back so that you can concentrate?
I wasn't even looking at it.
You literally haven't taken your eyes off of it.
I was
You were literally saying, I'm not even looking at it as you're looking at it.
Well, I wasn't paying attention to it. I was staring into space.
Oh, even better. All right.
I can't. You probably already know how to do this.
Here are the three values of absolute zero. These are These are the same values. And they're just the different units. So negative 459 degrees Fahrenheit is absolute zero, the temperature at which all motion stops. That's equivalent to negative 273 degrees Celsius. Why did we come up with a whole different unit for gases? All right. V1 over T1 is equal to V2 over T2. This is whose law? I don't know, Charles, something like that. No, it's not Charles. Is it Charles? It is Charles.
Yeah, Charles.
Okay. All right, so let's say I have that liquid nitrogen thing. And I have
Liquid nitrogen.
negative 200 degrees Celsius. And I want to know what my volume is going to be when I heat it up to room temperature, which is 32 degrees Celsius. So let's see, what was my volume? Let's say my volume here is 4 liters. What's my problem? I've got an issue if I solve it like this.
So you're switching.
No, I got the same units. These are Celsius. That's liter. What's my issue? Why? Why is that going to cause an issue? That I'm going to end up with a negative volume.
I was thinking it's going to be like negative 800 liters.
You can't have a negative volume. There's no such thing, right? Volume is the amount of space something takes up. You can't take up negative space. So you can't have negative values in gas law's equations. So they had to come up with a scale that doesn't have negatives. So what they did is they say, okay, well, the coldest temperature possible is negative 273 degrees Celsius. We're just going to call that 0 and make up a new unit for it, Kelvin, named after the dude that worked on it. Yes? So that's why you must use Kelvin for this entire unit. Must use Kelvin. So if I give you Celsius, which I will all day long, what are you going to do? Convert it to Kelvin. How are you going to do that? You add 273.
Oh. Ooh.
273. To convert Celsius to Kelvin. Yes, you add it to the Celsius number. I'll never give you Fahrenheit. Alrighty, Rudy. Pressure is next. Because Americans. I mean, legit, that's it. Because Americans. All right. The unit for pressure is either lowercase atm, which stands for atmospheres, lowercase k, uppercase p, lowercase a, stands for kilopascals. Gentlemen, there are people around you who are trying to focus. Lowercase m, h, capital H, lowercase g is the next one. This is millimeters, write small, millimeters of, what's Hg? Mercury.
I have a question. What about that one that Rose asked you about earlier today that she wanted me to ask you?
Tor.
Yeah.
We're not going to use it. And if I do use it, I'll give it to you. All right. Things to know about pressure. Match, and this is going to mean 0 sense to you. Make absolute 0 sense to you, but it will by the end of the day. Match R units to P units in ideal gas law. So you remember earlier when I said where R is and then I left it blank? I haven't told you what R is yet, and I haven't taught you how to use the units for R. I will by the end of this. But let's skip forward for now to volume. Volume is abbreviated capital V. It is measured in milliliters or liters. So milliliters or liters. You must use liters for ideal gas law. Can't use milliliters, you must use liters. And if I fail to explain that when I'm explaining R, ask me. All right, last is lowercase n. Which stands for your good old pal moles, which is abbreviated MOL. And I try not to use it because students think it means molecules. This is one of the few variables whose unit is the same as the variable, which doesn't make any sense at all. That's kind of like saying the volume is 5.0 volumes. It's dumb, but whatever. And you use moles for ideal gas law. So, good time. It doesn't have to be over that prompt. It could be anything sciencey. Just needs to be a page. Okay. So that's the table. Let's talk about this. At STP means that I literally just charged this. At STP means your temperature is 273 degrees Kelvin and your pressure is 1 atm. And then if you're needing to convert between the 3 pressure units, this is how you can convert between them. 1 atm is equal to 760 millimeters of mercury, which is also equal to 101.3 kilopascals. You shouldn't need those conversions except very occasionally. That's all.
Is that an and?
That's it. That's it.
What is
Oh,
it?
this is it.
Oh.
So
What does it say on the P equals what?
P equals 1 atm. All right. So let me show you how to use STPs. For who? Yay!
Smile, you're on video.
Oh.
1, 2, 3, Luna. When I was 13, I had my first love. There was nobody that compared to my baby. Nobody came between us, never come above. She had me going crazy. Oh, I was starstruck. She woke me up daily. Don't need no Starbucks. She made my heart pound. It's gonna be when I see her on the street and at school on the playground. But I really want to see her on the weekends. She knows she got me dazed because she was so amazing. And now my heart is breaking, but I just keep on saying, baby, 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 oh, like, baby, 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 oh, like, baby, 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 oh, thought you'd always be mine, mine.
Have a good day. Okay,
Back to me.
I want somebody to come see me, baby. I'm gonna yell at some people. I know. Okay, I need your attention. Hi. Ready? Okay. So, a couple of different things. How do you use these equations? Do I want to do this or R first? No, I want to do STP. Let's say I've got 5 liters of a gas at STP. This one phrase has 3 numbers in it. You see them? Volume is what? 5 liters. Temperature is what? 273 degrees, not degrees, Kelvin. Pressure is what? 1 atm. That's what this STP business means. It means standard temperature and pressure. It's the temperature and pressure that scientists have agreed to conduct all gas experiments at that temperature and at that pressure. Because remember, gases behave differently at different temperatures and pressures. So if we're going to standardize our results, they need to have the same temperature and pressure.
Wouldn't it be 273 Celsius?
It's 273 Kelvin, which is 0 degrees Celsius. It's the freezing point of water.
So then, is negative 273 degrees Celsius 0 K?
Yes.
Or did we already say that?
Yes. All right. Questions about STP? All right. So let's talk about PervNerd. This business here, the ideal gas law. Now, we need to talk about what R is. R has 3 values, and I don't want you to write yet. I want you to just absorb. All right? Here are the 3 R values. So don't write yet. I want you to just absorb. Because I told you that you match your R to your P units. right?
Mhm.
What do I even mean? Well, how about this? I have 5 liters of a gas, and it is at, let's see, it's got 3 moles, and it is got, I don't know, it's a temperature of 50 Kelvin, which is really, really, really cold, and a pressure, I want to solve for pressure in millimeters of mercury. So this is my variable. That's my x. That's what I want to solve for. And I want my answer to be in millimeters of mercury. So how do I know I'm going to use PervNert for this? PervNert. PV equals nRT. How do I know I have to use PervNert for this? Yeah, but there's something a little even more obvious than that. There's no change. Do you see? There's no before and after. I didn't say I have 5 liters of a gas. What is its new volume when I change the pressure? I have 5 liters of a gas, 3 moles of it at 50 degrees C. What is its pressure in millimeters of mercury? Do you see how I'm not changing anything? Yes. Yes, I'm just asking you to identify this gas. All right, so I've got volume. Volume is 5 liters. I've got N. N is 3 moles. I've got temperature. Temperature is 50 K. But what is my R? See if you can guess. What is my R? What R value am I going to use? There's 3 possibilities. Good. Do you see it? She says it's 62.4. How does she know? Look at the units that I gave you. Do you see how the only difference in the units of those 3 numbers are the pressure units? So this R works for gases that are reported in ATM. This R works for gases that are reported in kPa, and this R works for gases that are reported in millimeters of mercury. You do not have to get these memorized. I give you all chemical equations and the R values.
Yay!
Okay?
On like our test.
No,
Wow, Olin.
we just don't have to memorize them.
You can go ahead and fail it, but you don't have to get them memorized. Yes, of course, on the test and the quiz. Okay, yes, go ahead and write. These are the ideal gas constants. Oh. Well, it's geometry, but
Here.
yeah, definitely.
Yeah, but I have to like write everything to the trust.
That's fine.
How can I say I used to watch Why wouldn't I get home till 12:30? I mean, I was exaggerating a little. Most of the time, I just
I have to watch.
yeah.
All right, you got these copied? All right, this is what I need you to never do. I need you to never, ever, 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 ever actually use those.
Why are we right?
This is what students think this is. They think that's an equation that they need to solve. And so they're like, I'm going to plug in my liters there, and I'm going to plug in my moles there, and I'm going to plug in my Kelvin there, and then they don't know what to do. It's not an equation, they're units. It's not an equation. So I want you to never, once you pick your number, once you use these units to pick your number, I want you to ignore the units. Don't ever use them again. Do you see what I mean?
That's stupid.
Well,
No, because we just get the answers.
Look at you
Still
all.
have to do math.
Wait, but so what are the numbers for?
You plug it in for R.
so you just use these units to figure out which R to use, and then you ignore them.
Okay. I'm not even gonna ask.
Okay, rock on. All right.
No, you're just skipping.
Are we good?
We're not done yet. We're not done.
Wait, never mind. I can
You're scanning on that.
I've learned so
It's
All right, so this is how I solve these. The first thing I do, this is number 1 on your worksheet. Now, yes, this worksheet does break it up, Charles' law, then Boyle's law, then ideal gas. Just stick it in. But your test is not going to be like that, and your next worksheets aren't going to be like that. They're all going to be mixed up together. So how are you going to know which equation to use when? This is how you do it, Cooper. This is how you do it. All right. You go through and every... I need your attention. What is that? Pressure, temperature, or volume? What is this? Pressure, temperature, or volume? What will the volume be? Uh-oh, I've got another volume. If the pressure is raised to, all right, what's that? All right. Now you use context clues to figure out what's 1 and 2. So context clues, not the order in which they appear. Context clues tells you that this is V1, that's P1, so therefore this must be the 2's. Once you have identified all your variables, you pick your law that you're going to use. You go up to the list of laws, and you're like, the only one that covers P1s and V1s is Charles, right? Is it Charles?
No, wait.
No, it's not
No,
Charles. It's
not.
Boyle,
It's-
right?
Yeah.
So P1, V1 is equal to P2, V2. And then you no. Good.
When in real life are we gonna use it?
if you're a
Thank you.
chemist.
When you become a chemistry teacher, you have to teach it to the next generation. All right. Questions on this?
So then we just solve it like an equation?
Yep, you just solve it. You solve your unknown. Those of you who are a little math, don't forget cross multiply and divide for fractions. So for this one, so let's say I've got P over T is equal to P over T. 1, 2, 1, 1, 2, 2. And I want to solve for this right here. You cross multiply and divide. Remember that? You do the butterfly. All right. I can get busy.
We're done now? So later. I don't.
Okay, yeah, a word on sig figs on this worksheet. I'm sorry about sig figs on this worksheet because too many of them round to 1 sig fig. Look at the first one. Yeah, the first one, you have 2 sig figs, 1 sig fig and 2 sig figs. So how many sig figs do you use?
One.
1. All right, so it's going to make a really imprecise answer. So what I did on the key is I gave you the not rounded answer and the rounded so that you know if you're doing it right. Yes.
That's not right. Yeah, that's the sig fig. Okay.
Okay, that's what I was thinking. Because I was like, it was giving me the exact same thing that already was in the first place.
Oh my gosh.
Wednesday, I believe.
I probably failed again. Volume stayed the same.
You haven't done any practice.
Tell me I'm wrong. Okay, then that's why you're not good at it. Adrienne, shall you get busy?
Hey, I'm dealing up my food right now.
Oh, I don't blame you.
Bye.